Hi all, welcome back. And in this video, we are going to learn about how to write relational queries using the relational algebra. But before that, before jumping on to queries, I would like to throw some light on to the previous topic we discussed on to relation, and let's solve a question based on relation to find out the number of tuples. So let's say we have a relation R and it consists of X attributes. Okay, so the number of attributes in relation R is X, and let's say R has n distinct tuples. So there are n distinct rows. Okay, so this is given. Now, let's say we have another relation, relation S, and relation S is having Y attributes. Total number of attributes in relation S is Y. And let's say in relation S, we have altogether m number of distinct tuples. So we have m distinct tuples in relation S. Now, if we need to use the condition, if we are asked to use the condition of R divide upon S. So condition to use R divide S, it is simply equal to R has to be the subset, not R, X has to be the subset of Y. Okay. So for this condition to use, we need to have X which belongs to R. It has to be a proper subset, or not just subset, proper subset. Y has to be a proper subset of X. Okay, so X has to be a super set of Y. So this is one condition, and another is R divide S expression always results into X minus Y attributes. X minus Y attributes. And regarding the cardinality, if we talk about, then cardinality of R divide upon S. So the minimum number of tuples could be 0, because if we don't have any such S, which is we don't have any such attribute in R which is mapped to every attribute of S, so it could be 0. And the maximum tuples could be the number cardinality of R. Okay, so it could be n divide upon m, and we are taking the lower match. Okay, so n will be the number of tuples in R. So we are dividing n upon m, and we are taking the lower bound. So this is very important. That's why I wanted to discuss this part. Now let's see some more attributes, like if R has n tuples. Okay, so if we say that relation R has n tuples and S has 0 tuples, let's say. So if we want to find number of records of R divide upon S, then it is at most n tuples. If we are having the distinct records, and if we say that distinct records of R minus S. So R minus S is the total number of distinct record in R divide upon S, and that is R minus S attribute set. Okay. So this is one condition when S has 0 tuples, and then if we want to find the number of records in R divide S, so in that case it will be at most n tuples. Okay, at most means from 0 to n, and distinct record of R minus S will be the R minus S attribute set. So the important point here is this one, that how to calculate the cardinality of R divide upon S. So minimum will be 0 and maximum will be N divide by M, because we can't say here N, because of if we are saying N tuples, then we are not sure that all the tuples are distinct. Okay, so if we know the primary key of R, so we can say that okay, it can be distinct based on the primary key, but here we are talking about the number of tuples. So the number of tuples, and here we are talking of M. So the maximum can be like if every tuple is distinct and every tuple has a unique mapping with M, so we can define it like this. Okay, uh, let's take an example of this part also regarding the cardinality of R and S. So let's say we have something in like in a relation R, we have AB, something like A1, B1, A1, B2, A1, B3, A2, B1, A2, B2, and A2, B3. So like this, we have the attributes in R, A and B. And let's say in S, we have the attributes for B as B1, B2, and B3. Now, if we need to find R divide S, so what is the cardinality of R divide S? So we can find from here that the cardinality will it will include the attributes of A, and also we see here that R is a superset of S. Okay, so now it will include the A, where every A is mapped to every B. Okay, and then every we'll see A2 is also mapped to every B. So for A, if we take all together, there are six tuples. So for each of them, we have to divide by the number of tuples in B. So the maximum, if there is a mapping of every attribute of A with B, then the maximum number of tuple is A1 and A2, which is nothing but 6 divided by 3, and that is 2. So 6 corresponds to the number of tuples in R, that is N, and 3 correspond to M. Okay, so it is N divided upon M, and we are taking the lower bound. Okay, so yeah, this is all about division. Now let's see some of the relational queries, how to write some relational queries. So let's say if we have to find the SIDs, okay, enrolled enrolled every fourth course. So here, whenever we talk about every course, so we can say that we can take the from the SID CID of enroll, we can divide it by CID from the course where instructor equal to course. Okay, so this way we can divide, and this will give us the SIDs of enroll where instructor equal to quote. Okay, we can also write it some way in an expanded format. So sometimes you can see it being written in this format. So we are taking the SIDs from enroll, and we are subtracting the SIDs who have not enrolled every course. So SID of enroll into SIDs, sorry, CIDs, where instructor equal to a course, where instructor equal to course, and into and we are subtracting from here. Just a second. And we are subtracting from here SID, CID of enroll. Okay, so this way we can find out that all the SIDs which have not enrolled the course, and we can subtract it from enroll, and that will give us the SIDs that have enrolled every course. Okay. Next, like we can find out something like if we need to, like retrieve CIDs enrolled every student, every student whose age greater than 20. So we need to retrieve the CIDs who has enrolled every student whose age is greater than 20, right? Now here, age greater than 20 will be coming from the student table. So first we need to find out the SIDs whose age is greater than 20, okay? So for this, we can do something like, first we need to find out the SIDs where age greater than 20 from the student table, and here this will give us the SIDs, and then we will multiply this with every CID from the course, and now this will give us the pairing of all the students with age greater than 20 with every course, and from here we will subtract the SID CID from course, sorry, from enroll, and this will give us all the students whose age greater than 20 and who has not enrolled in every courses. Okay, so if we have this, so from this, if we so we need to subtract it from the SIDs of enroll. So this gives us the SIDs of the students whose age greater than 20, SIDs of student whose age greater than 20 and not enrolled in every courses. Okay, and if we are subtracting this entire part from enroll, then it will give the SIDs of a student who have enrolled every courses and whose age is greater than 20. So this way we can do this, and if we want to represent in the form of okay, we need to retrieve the CIDs, right? So okay, just a second. So here, sorry, we need to retrieve the CIDs, right? So for that, we have to replace this part, and we have to SID into CID, and here we have to place another thing. So just a second. So here we will write the CIDs, and here we need to take the CIDs from the SID CID field. Okay, I might have done the same. Okay, it's fine. So here we need to retrieve the CIDs, and then we are subtracting it from the enroll CID, right? So yeah, this way we can find other way of using, we can use the division operator as well. So that is equal to CID SID of enroll, and we can divide it by SID of student, and we need to add one condition on student, that is age age greater than 20. Okay, so this way using the division operator we can retrieve this, right? After this, I think we have done enough of the retrieval for division. Now we will see some more retrieval, writing, how to write a relational queries for some of the statements, like relational algebra statements we will be given, and for that we need to find out the relational query, how to query those statement. Okay, so we will be looking for that in the next video. Till that, if you do have any comment or question, you can post your comments or question in the comment section, and thank you very much for watching the video.